Thank you all. So my name is Ramesh Dwarkanath, and I'm a Principal Solutions Architect with AWS. So today, as Ron was mentioning, what I want to talk about is, really what are we, what are the reasons why we want to create a hybrid architecture? What are the typical challenges that companies face that requires a hybrid architecture? Then we go into what is the AWS approach to architecting a hybrid or an edge workload, right? And as part of that approach, then we're going to go into talk about some of the services that encompass and that can be utilized for each of these scenarios. And then we'll finally go ahead and kind of double click on a few of those services and talk about things like Outposts, for example, go into a little bit more detail, describe that and how that might be leveraged or used by all customers. So that's kind of a high level. Again, given the time frame we have, we may not be able to go into too much of depth, but I want to at least leave people with a general understanding of what is it, what is hybrid, and why do we need hybrid architectures, and that's something that's very prevalent today, right? Large enterprises are looking to move on to the cloud, and that's definitely everybody's doing that. But not everything can move to the cloud, or there are some reasonings why you would not want to move a particular workload onto a cloud and so on. So we look at some of those reasons for the hybrid architecture. Did the screen change? I just want to make sure because sometimes you have challenges.
Let's see, I can see right now latency, jitter, hybrid edge drivers.
Perfect. Okay. Yep. So that's great. So basically, if I want to sum this up, right, in terms of how do you want to run? Why do you want to have a hybrid workload? What are some of the drivers for a hybrid architecture, right? So this Venn diagram actually nicely describes all the factors. And some of the important factors are service usage, right, which is really influenced by where the customers are located, what are they trying to do, their mobility, they're all on their, all over the world and moving around and on their mobile and so on and so forth. And then, and the latency or the jitter, right? If I'm trying to access something and it takes a long time, that's not a great experience. Then you have security and connectivity. That security is always a challenge, right? Always something that everybody has to keep in mind to make sure that whatever transactions, whatever data, whatever interactions that you're having with the customers are having is secure. And again, that's influenced by where the customer is accessing from, and also kind of the bandwidth, right? So in terms of the connectivity, how that is set up. And then finally, you have the quality of experience, right? So that's kind of driven by the latency and the bandwidth. So, how much bandwidth do you have and how much of latency? Again, some of those things, latency is sometimes, just where you're physically located. And it's the laws of physics, right? You can't necessarily change the distance itself, but you can do some things to kind of mitigate some of those aspects. So that's really where, some of these are the drivers that kind of drive that. And then we'll go into a little bit more into, what the AWS approach is. So what is the, our proposed approach is really kind of fairly straightforward and simple, right? So we approach everything just like we approach any other, workload or service or whatever. We say, okay, what is the use case? What exactly are we trying to, solve here, right? So you have to define the edge use case, right? We have to capture the business drivers, right? So that is always key. What is the business outcome? What is the business driver? What is it that we are trying to achieve from a business perspective, right? And that's what we call in Amazon called working backwards, right? So you're looking at the problem, you're talking to the customer, and then working backwards from there to figure out what the challenges are. And then you look at other alternatives and so on and so forth, right? And then you go into the architecture piece. So you kind of whiteboard it, figure out what are the different pieces, where are the users located, where is the workload, what kind of bandwidth do you need, what kind of latency are we talking about, and so on. So you kind of also define what the different services are, like what are we looking to leverage, right? And then from an analysis point of view, kind of going into design considerations, again diving deep into what are the challenges, how do you design the application, because a lot of times it's not just the infrastructure, right, but it's also the application that is built on top of that infrastructure that needs to leverage that infrastructure appropriately. And so we go into that. So it's fairly common. I mean, just like any other design you would want to do for a workload is the approach that we would take here. Then we go into these specific use cases, right? What are some of the use cases? And here are some of the common hybrid cloud use cases that we typically see with our customers is, low latency applications. There are certain applications that cannot, survive a high latency, right? So there are some type of like financial applications or gaming applications and so on. You want to modernize your application architectures, right? And developer efficiency is a big deal, right? So you want to make sure that developers are expensive today, right? And you want to make sure that they're working on the most impactful things that you would want them to work on. You want to data residency. That's a huge thing, right? Because there are either laws governing it, there are regulations, and certain data cannot leave certain countries, and certain it has to be in a certain area, certain region, and so on. So that's a big deal that a lot of our customers go through. A lot of enterprise customers run their load on VMware, right? And so how are you able to deal with that? How are you able to move that onto cloud, or how do you make that transition? Things like that. So that's another use case that we look at. Disaster recovery, right? So disaster recovery is really kind of cloud bursting is really cloud becomes an extension of your on-premises infrastructure, right? So if you want to, move out to the cloud for whatever, either from a scaling perspective, and if your applications can handle that, or from a disaster recovery point of view, you want to be able to, leverage the cloud, right? If everybody eventually needs to move to the cloud, and this is a good first step to do that. Moving the enterprise applications to the cloud, that's a big plus, right? So you're trying to modernize your applications. You're trying to make sure that your applications that have been built on pretty much legacy infrastructure, right? You're able to take advantage of some of the some of the features that cloud provides, and then to be able to process your data locally. Sometimes there is a need to process your data right at the place where it is generated, right? You just don't have the bandwidth, you don't have the the time or the latency or whatever, right, to be able to send the data to the cloud to process, and you want to be able to process that locally. Building on that, right? Some of the other things that when you're designing this, some of the other things the customers want is, no matter where the customers are consuming the cloud, they want the same experience they would receive in an AWS region. Meaning they want the same reliable, secure, high performance infrastructure used in our AWS regions, right? Which gives them the same security mechanisms and controls, predictable performance, and consistent operational model, right? So, and that's basically by doing that, leveraging, and you want to be able to leverage the same set of services, APIs, and tools, which is really very important, because when you're building those applications that enforce the audit and security and audit and so on, right? You want consistency in all your cloud workloads. So all of those, right? You want to have a very similar experience that you would want to have, that typically you would get on a cloud, right? And that's one of the key aspects of it, of designing, right? Aligning to key IT initiatives. That is super important, because you want to make sure that whatever your customers or organizations are doing, and these are kind of very typical buckets of activities that are happening. There's either some sort of migration happening, there is modernization of the applications and the infrastructure happening, disaster recovery, right? Planning for disaster recovery, making sure that you have a good disaster recovery DR plan, and then leveraging for your test and development environments, right? What do you have? Can you keep buying new infrastructure? Is your existing infrastructure sufficient for that proof of concept, something that you can easily fail fast, right? And throw it away, those kind of scenarios where you're kind of having like a sandbox environment and things like that, right? So migration modernization is fairly straightforward, right? So you have your key pieces, like you have your VMware based applications, right? And you want to be able to seamlessly migrate them over to cloud, right? So that's one use case. You want to have, like, there are some data center consolidations, right? You're trying to get rid of your data centers, or maybe consolidating them into one or two data centers and so on. Again, it's all kind of cost driven, right? And today's environment, everybody is cost conscious, and not just that, it's best practice almost, right? With given the power and the maturity that the cloud has reached today. And then you have like hardware refreshes that constantly happen, and how do you manage that? And it's a lot easier to manage that in the cloud, right? And disaster recovery, right? So you want to be able to fail over to AWS regions for scalability and to achieve again cost efficiency, right? So you can right size your instance. You don't have to keep running the instances all the time. You don't have to build out or buy a whole set of infrastructure for DR purposes, which for the most part are not being leveraged, and so on and so forth. Those are the usual challenges that people typically run into, right? And you want to get over that. And then we already talked about the test and development, right? Now, given all of these conditions, right? So we talked about some of these, key initiatives, and then we talked about, what the experience the customer wants, and what are the different use cases that typically customers go through, right? What is the AWS approach, right? So the AWS approach really is AWS meets customers where they are, right? Physically and technologically, right? What does that mean, right? So AWS has created hybrid cloud and edge computing models to provide a continuum of consistent cloud services, right? Wherever you need it to support your business, right? Whether that's an on-premises data center, or a smaller location like a retail store, or a major city where it's not really cost effective to have a big data center, right? Or on the edge of a 5G network, right? Or for a company that develops applications that delivers ultra responsive user experience, right? Now, this continuum of services, right, starts in the AWS region. So if you look at it from one end of the spectrum, right? So you have the AWS regions with AWS global infrastructure, providing the widest range of services and offerings to customers, right? Next, if you move on, we bring the cloud closer to users in specific geographies with services closer to metro areas or telco networks, right? We even provide services for on-premises data centers, which can be managed by AWS or by the customer, right? And this is something where we'll go into a little bit more deeper talk about a little bit more about Outposts, right? And in the metro areas, we'll talk a little bit more about the wavelength and local zones and services that we offer. Now, we have services that go even further, right? Like remote and limited connectivity locations where AWS customers can take advantage of cloud services like anywhere in the world, right? And again, it's one of those offline capabilities that you can get, things like, we talk about like, Snowball and Snowball Edge, and we'll touch upon that a little bit later. And lastly, we also support services in the farthest and the smallest edge, like in smart devices, buildings, factories, with more services with the IoT, right? Internet of Things. So that's kind of really on the shop floor, manufacturing, getting the data, getting the metrics, and to be able to process that right there locally, or even back in the cloud itself, right? And with all of this, right? Why are we trying to do this? What is the reason why AWS is trying to trying to meet the customer where they are, right? Because when you have a truly consistent experience across all environments, right, you can accelerate your innovation, right? So basically, you're writing your applications once and then deploy them anywhere, right, with minimal application changes. You can manage a broad base of global infrastructure using the same skills and tool sets. That is really, really critical, right? So people, you don't have to necessarily hire people, train people, and so people necessarily don't have to learn new tools or buy new tools and so on, right? Basically, it all adds to the cost and operational efficiency aspect of it, right? And then finally, you want to adopt cloud security wherever your applications and data are and meet the same stringent security standards that AWS applies in the regions, right? So we're trying to replicate what is available in the AWS regions across the board, no matter where you are located, right? We want to create that consistent, secure experience. So applications have different needs, right? While most applications can be easily migrated to the cloud, there are some applications that need to be re-architected or modernized, right, before they can be moved to the cloud. And some really need to remain on premises for the foreseeable future due to either they have a low latency requirement, there's a local data processing requirement, or a data residency requirement, right? These applications have to then reside in on-premises data centers or maybe branch offices, manufacturing plants, restaurants, edge nodes in large metro centers and 5G networks and other remote locations, right? In addition to existing legacy on-premises and edge workloads, the basic three trends that we are seeing, right, that is fueling the need to support applications where they might need to reside outside of traditional cloud regions and availability zone, right? The first trend is an emerging class of new applications, right, that require ultra low latency, some such as like real-time gaming, right? Video streaming, AR, VR, autonomous vehicles, content creation, engineering simulations, right? And ML inferences at the edge, right? So these applications are deployed in on-premises data centers, branch offices, hospitals, factory floors, retail locations, and at the edge in cell tower sites, or even near the scientists, right, doing their experiments, engineers, artists, and so on, right? And end users often access these ultra low latency applications on mobile devices. So they need to be deployed at the 5G network edge, right, to take full advantage of the speed and bandwidth and benefits of 5G. So that's kind of the first trend we are seeing. The second trend is local data processing. Customers are generating tons of data, right? Enormous amount of data in their digital transformation initiatives, and they're increasing their implementation of IoT devices and so on. So some of these are required for local data. And then finally, you have your third one is data residency, which is security and tax regulations and data sovereignty. So those are kind of the main pieces where the types of applications for the reasons why you want to be on-prem or closer to the outside of a region, of a cloud region. So essentially, from a AWS for an edge point of view, right, we have what is called as three main services. One of the three services that we look at. One is like AWS local zones, which really brings compute, storage, database, and other select AWS services close to large population and industry centers, providing lower latency for demanding applications like media and entertainment, content creation, gaming, and so on, right? And the second one is AWS Outposts, which really puts AWS native cloud infrastructure and services into on-premises, right? So there is actually a physical box that gets deployed into your data center, and you get that, and you get all the AWS services with that. And then AWS Wavelength, which is essentially for applications with low latency requirements deployed at the 5G network edge. And then you have I touched upon the Snow family, which is really kind of the offline storage and compute resources. And again, just kind of keeping time in mind, I'm not going to necessarily go through each one of those, but essentially, like we said, these are really deployed in large metro areas, local zones, for essentially the metro where you have media entertainment and some of the content creation happening, right? So some of the examples, we talked about, from a latency point of view, from a location point of view, and from modernization point of view, right? That's where you would want to use a landing zone. Now, coming into highlighting a little bit on the AWS wavelength piece of it, again, 5G capabilities today that are has opened the door for so many opportunities, right? So we want to make sure that wavelength, which leverages 5G capability, is able to help with the customers on leveraging the underlying 5G technology, right? So you really get that massive connection density, ultra low latency communication, and the bandwidth, right? And you want to be able to leverage that. And just to kind of highlight that, right? So you have a single pane of management in the cloud that you are providing the same APIs and tools, and you're leveraging the underlying 5G network to be able to deploy applications, right, from regions to the 5G enabled edge locations. Snowball Edge is a type of offline device. It's got storage and compute built into it. It's basically meant for remote locations where you may not have good connectivity, internet connectivity, or you may have spotty ones, or you may have no connectivity, right? And you want to be able to process data locally. And that's really where you would want to use. So you have like two types of Snowball Edge options. One is more compute optimized, and the other one is storage optimized, right? And getting into Outposts. And Outpost is essentially, it's a logical construct, right? To where you can pool capacity from one or more racks of servers. So this is like a rack of server that we deploy and is managed by AWS. It's deployed in your data center and essentially shows up as another availability zone in the AWS console. So, if people are familiar with the AWS console, and I actually looked at a VPC and network construct, there is availability zones, and this would show up as one of those. So it's it neatly integrates and with the console itself and provides you all that information. So again, there are basically three types of three form factors. One is a single server, another slightly bigger one, and finally you have a full rack, a 42-inch rack, 80-inch rack, and essentially that is really where you can run services. For example, things like you can run at your retail stores, right? Some of the smaller ones, the 1U and 2U ones, you would use it at a doctor's office or a retail store, a point of sale, or a factory floor, right? Those would be the normal use cases for a 1U and 2U. But essentially, all of these different form factors are servicing all of these services, right? So you have all of these are again standard AWS services that run in AWS regions. Now you're able to run locally in your own, either on premises using Outposts, right? In any of these different form factors. So that's the power that whatever services that you were comfortable with or you were familiar with running in a region, whether it is container services or it is caching services or it is database services, right? You're able to run all of that on in your local hybrid environment. And then finally, just to kind of give a high level perspective around the architecture itself, right? So if there were a bunch of for gaming clients, servers that were connected directly to a region, right? Depending on where they are and from the region itself, they may not be closely located to the region, right? So you see some level of latency, and there is a little bit of a variance that you get between depending on where the users are, right? Now, if you replace that and insert essentially your Outpost into a data center, now all of those users were probably connected to a data center prior to connecting to the region, right? And say we pulled out the data center and directly plugged them into the region, and we saw those variations. Now, instead of that, we basically put in Outposts and give them access to this, to the data center itself. Now, you have the advantage of expanding to the cloud, the power of the cloud behind, right? And in the front, you still have that same latency maintained with your end user. So you kind of get both the advantages at the same time with Outposts. And then finally, I want to leave you with the thought about the shared responsibility model. This is kind of one of the fundamental models that we have at AWS. Essentially, what it means is there is a customer responsibility and there is an AWS responsibility. So AWS is responsible for the infrastructure itself and the foundational services like the compute and storage and databases and networking and so on, right? And anything above that, is the customer's responsibility. However, in the case of Outposts, there is that central, there's like that gray, middle area, right, where we have actually deployed infrastructure in your data center, but we manage it, right, and we are responsible for that, right? But all your data itself, like, is your responsibility, rightly so, right? Because you own the data. You have complete control over how you manage your platform, your application, and so on, all your configurations, right? That still remains the same. So that's kind of your responsibility on top of that. So with that, I know it was a bit rushed, but I just wanted to hopefully give you a sense for, what a hybrid, what are the different reasons why you want to be on a hybrid architecture infrastructure, and what AWS brings to the table.